Greetings. We are from Group 5, and today we're going to talk about characterizations of the key aroma compound in Chinese Vidal Icewine by using gas chromatography, olfactometry, quantitative measurement, aroma recombination, and omission tests. So these are team members, Nay, Prom, She'em, Prao, and Tree. So let's go to our table of contents, the one we will be covering. We will start off with introductions, followed by objective, then material and method, and ended on result and discussion. So what is ice wine? Ice wine is produced from grapes that have frozen naturally on vines under the temperature of -8 degrees Celsius or below. The frozen grapes on vine will be air dried, shrunk, then picked and pressed and in a continuous process while they are still frozen. The frozen grapes on vine will finally result in wine concentration with sugar, acid, pigment, and flavor. So aroma is one of the most important factors that determine the characters of wine. It can also influence perceived wines and consumer acceptance. In recent years, studies on ice wine aroma have shown that aroma contribute to ice wine differ substantially from different regions of origins. So the volatile compound in ice wine determines its aroma profile. Identifying these volatile compounds and clarifying the contribution of key odorant to overall aroma are important to ice wine quality control. So next is the research gap. Prior researches mostly focus on identifying and quantifying volatile compound. Not many studies how each compound contributes in creating the aroma profile. So in this research, reconstitution study is the approach taken from confirming both findings with qualitative data. A prediction of key compound was initially made by referring to studies of ice wine from other regions. Gas chromatography-Olfactometry or GCO, which was used to determine odor active compound from the ice wine in chromatographic run. And lastly, recombination experiment and omission tests were used to verify and rank the aroma contribution compound. So moving on to the objectives. The first objective is to identify the key aroma compound in Chinese Vidal Icewine. And the second objective is to determine the contribution of different aroma compound to the profile of Chinese Icewine by using GCO, quantitative measurement, aroma recombinations, and omission tests, which will be clarified further on.
Next up is the materials and methods used in the studies. Starting with ice wine samples, there were 3 experimental ice wines based on the level of pressing: black label, blue label, and yellow label. The black label ice wine received the lightest pressing, followed by blue-yellow, and yellow label having the highest press fraction. Some additional details about their production. Grapes were harvested, destemmed, crushed, and pressed at freezing temperature. Then, the grape juice was transferred to a stainless steel container for stabilization, fining, and filtration before bottling. And the samples were commercialized after 12-month aging time. All samples were stored horizontally at 18 degrees Celsius in the dark prior to the analysis. For the aroma extraction, the solid phase extraction method was used to extract volatile compounds. The column used is the lithium chloride EN, which has both polar and nonpolar interaction sites. 50 milliliter of the sample passed through the column, eluated with dichloromethane after washing with waters, sugar, pigment, and other low molecular weight polar compounds were eliminated, leaving the organic phase concentrated to a final volume of 250 microliter. In GCMS, the analytical columns were DBFFAP polar column and HP5MS nonpolar column. The front inlet was programmed in splitless mode for SPE, and the oven temperature was initially held at 50 degrees Celsius for 2 minutes, then raised to 230 degrees Celsius at 6 degrees Celsius per minute and held for 15 minutes. The carrier gas was helium at constant flow rate of 2 milliliter per minute, and the effluent supplemented with helium was split to the olfactory port installed at the back of the GC detector. For GCO analysis, it was conducted by a panel of 4 well-trained assessors. Retention time and aroma characteristics of each compound at their peak. Only odorants that was detected among the assessors by more than 2 people were recorded. Also, the ratio of the peak area of the compound relative to the peak area of the internal standards was used to determine the concentration of analytes. In conjunction with GCO, aroma extract dilution analysis was used for searching important odorants. The concentrated fraction was diluted stepwise at 1:3 ratio between sample and dichloromethane. Each dilution was submitted to GCO analysis under the same GC conditions until no odorants could be detected, and so the flavor dilution factors was obtained. Analyses were repeated in duplicate by each assessor. Only the odorants detected among more than 2 assessors were recorded. This is the table listing data of chemical standards. The quantitative methods use SPE, which stands for solid phase extraction gas chromatography mass spectrometry, SPME for solid phase micro extraction gas chromatography mass spectrometry, and SPMED, which is the same as SPME but done after chemical derivatization. The internal standards used to quantitate the compounds were IS1, L-menthol, IS2, octyl propionate, and IS3, p-fluorobenzaldehyde. On the right side, LOD stands for the limit of detection. The value represents the lowest possible concentration that the utilized method can detect. Given the methods using, the LOD of ethyl acetate, isomyl alcohol, and phenylethyl alcohol were relatively high compared to other compounds, meaning that they must be present in higher concentration to be detected. The next table was the recorded experimental data of aroma compounds in Vidal Icewine from AEDA and DCMS analysis. Since this table has a long list of compounds, it was separated into 2 pages. Recall that DBFFAP column was polar and HP5MS was nonpolar. The overall comparison between linear retention index LRI and experimental retention index RI of all listed compounds were relatively close. That supports the identity of the compounds. In FD columns, data that were underlined indicated the possible effect from different press fraction. Yellow lines highlight that of the highest press fraction from yellow labeled sample, and the same goes for black labeled sample with the lowest press fraction. underlined by black line. One point of interest in this table is that the compound beta-damascenone only showed same FD values. No, not only showed the same FD values, but also the highest from all three labeled samples. This is the test that reaffirmed the data obtained from the experiment. Recombination test was about recombining molecular components at the amount based on the experimental data to be compared with the original sample. So following the illustration shown on screen, the sample was made odorless. Then the aroma compounds were added in. Now, if the aroma profile of the recombined ice wine matches with the one from the original ice wine, the data obtained from this experiment would be valid. Last but not least is omission test by discrimination analysis. Basically, it is a test to tell the significance of each key aroma compounds in contributing to the overall aroma profile. Triangle test was used in the study with 3 test samples consisting of 2 identical ones and 1 with a key aroma compound missing. Results were recorded in a scale of how much the test sample matched the description of the aroma.
Next, we have come to the results and discussion. So for the first one is the results from aroma compounds by GCO in ice wine. So first, we found that the sample extracted by the SPE represented exactly the typical ice wine aroma profile. Thus, it was reliable to be used to analyze the ice wine key aroma compounds. And a total of 95 and a total of 59 aroma compounds were recorded by the GCO. The yellow label ice wine held the highest total of FD values among the 3 ranks. And aroma compounds existing in the 3 ranks were almost the same except some compounds that like in the yellow label ice wine. The important aroma compounds found are in the below table, with the Adore description by GCO, FD from AEDA, and RI both column via GC. They found significant aroma compounds, which will be elaborate the next slide. So the first one is beta-damascenone. Due to many reasons, it was determined to be the most important aroma compound in ice wine. It significantly had the highest FD of 2,187. It was described as honey-like flavor, although it was often described as the cooked apple flavor. This may due to the difference of the concentration, which result in the different aroma profile. The next one is methionol. Its FD was more than 81 in all 3 ranks. It was described as cooked potato flavor, and it could be sourced from L-methionine, which was contained in the ice wine. It could be formed by Schrager degradation or by sulfur metabolism in the yeast. Its contribution to aroma profile was not sure using this GCO, thus the recombination and the omission test should be performed in this context. And the last one is furaniol. It has a different in FD among 3 ranks, which is lower in blue. It was described as the caramel flavor, which this compound will be described as caramel-like in the concentrated one, but in the dilute solution, it will be described as a pineapple strawberry-like odor. It is a product of Maillard reaction between an amino acid and a reducing sugar, which were rich in ice wine. Next one is the results from quantitative analysis in the yellow ice wine. Next is the quantitative analysis in yellow ice label ice wine. They use only compounds that had FD more than 9 to further quantitate. So total 28 compounds were quantitated via the method prompt as mentioned to obtain the concentration as shown in the first column. Then the concentration would be used to calculate the odor activity values or OAV with the thresholds. However, since no reference for thresholds of these aroma compounds in ice wine metrics, these calculation was just an auxiliary approach to understand the contributions of different compounds. 22 of these odorants were further verified as important odorants in Vidal Icewine with the OAV of more than 1. The next one is the results from aroma recombination and the omission experiments. First is aroma recombination to confirm the contribution of 28 of those compounds with FD values of more than 9 in Chinese Vidal Icewine. They were recombined in odorless ice wine and compare with the corresponding real wine. The aroma profile of them were similar, but still had some intensity difference with the original ice wine on the apricot, honey, and tropical fruit flavor. Then they did omission experiments. They prepared 7 aroma omission models based on their aroma descriptions and compare with with a triangle test. The results are in the right-hand table. They found that esters were one of the key groups for ice wine as the model without those esters were recognized by oxesters as well as the beta-demasquinone. The rest of the models were also recognized in some levels. Then the descriptive analyses were used to explore the aroma contribution of the certain compounds, namely beta-demasquinone, furanil, and methionine. The results are on the left. The model without beta-demasquinone was evaluated with a very highly significant difference for every characteristics, resulting in the loss of every ice wine type flavor. Furanil and methionine also showed significant effects on ice wine character, especially on apricot, caramel, and tropical fruit characteristics. It was implied that these 2 compounds were important to Chinese Vidal Icewine. So, preliminary understanding of Chinese Vidal Icewine aroma compounds. However, there are some limitations in this study. So the researchers suggested that first, further emphasis should be on study more vintages like the year or place in which wine, especially wine of high quality, was produced. And second, the aroma compound thresholds should also be measured in the ice wine model system. And this is our reference. Thank you.